sorry if last video I fumbled a lot, but we're going to be making the CPU architecture, blah blah blah. So we're gonna make our drawing, and let's start. So let's start. Here's gonna be the in. This is not gonna be conceptual, it's gonna be the full thing. So then, going to the control unit, CU, just connects here. Then we have the registers. Two-bit, 16R. We connect to these, and then we're next to our conceptual design. Now we got to add this thing called a program counter, and a register file. I think a register file holds the next instruction. So we can have this here, and then this will go here. Bada bing, bada boom. Have you guys watched the thing that was like Austrian painting? Yeah, it's pretty funny. I don't know who it's by, but I remember. So then this register file goes here, and the program counter counts what instruction we're on. So so there's gonna be it's short for PC. I'm gonna add like this small thing. This is gonna be like the bridge, because I'm lazy to move all the lines together. So then we add these lines. It connects. Bada bing, bada boom. We have it. And then finally, it's gonna go to the ALU. So it's gonna be multiple ALUs. And finally, is going to be out. Just a disclaimer. The bus. So I'm just gonna write a disclaimer. Buses are moving stuff. So the buses are used to move stuff in between. Let's just say there are 4 buses. I don't know. To send 4 data. No, it's 1632. 4 32-bit buses. I don't know. Don't ask me. But we have this. Bada bing, bada boom. So we're gonna save and close. And this is here. We got our PC design. And I'm just gonna take a little bit of time explaining this. Psych. Now that we have the architecture, I can show you how this is gonna be moved. Yay! So basically, if you don't know, we're using OCTA ALPHA, not hex. This is something we made. You see, what we have here So, this is an example of Dr. Alpha. You see, we have A1 plus B1. You can write, this will be in binary, essentially. But these all equal to one thing in diocta alpha. So we can write instructions like this. And to make the instructions shorter, we add these strategically, making a big instruction. So that comes with the combined instruction. This would be C2. But what we're doing is we're increasing the speed. Now here, I want to ask you to please subscribe, bro. I need that money, bro. I need to get monetized, please. Anyway, when we do this, then we can shorten an instruction. Let's say an instruction is like A2, A2, A5, C3, D4. Now, instead of making it full like this, we can just add these together. Bada bing, bada boom. And this will become, that is B7 plus, that is plus FA7. FA7. And then we press equal. And then now we can add that. That becomes FC. FC. Well, technically this will become AA, but you see the point, right? Becomes AA7. This becomes, you add here, becomes AC. That's 14, so that'll be a D4. So, look, this would be, so by 6, that is 6, 12, 18, 24, 30, 36, 42, 48. That is 48 digits. Well, this is only 18. You can see the wide difference between these. Now, I do want to actually make this in real life. All of this will be part in the series of creating a computer, because I want a better computer. So, yeah, now let's go on to create. That's how it works. Now, let's show you how this works. So, diocta alpha, we have A1, we have A2, and it goes on for some time. So, I can copy this, and let's just do these. And then we can change this, so it'll be the same. And we can finish this up later, but I'm just showing an example. And then this goes to 10. So this is basically A, B, C, D, E, F, G, H, I, J, I think. I haven't memorized it, but this is essentially how it goes. So, you guys can maybe comment that I can maybe fix this. But if I just want to explain this, we have the in. This is where instructions come in. And we can send stuff to the control unit. But the register file also is the next instruction. So if we directly send it, we can cycle through sending stuff to make it faster. And then we essentially send it to the register. And then it gets sent to the program counter, which piece by piece sends it through to the ALU. This will be the decoder or something. Don't blame me. Blame my brother-in-law. Well, so this will be a decoder. We'll have to add a decoder, but yeah, this is essentially it. So, see ya.